Alright, Baz, this is mostly for you, but the listeners, you can pay attention too. This is on white dwarfs, nova, and stellar youth. Cut and paste as you choose, Baz. Page 236. White dwarfs are the youthful stars in the general theory. Therefore, some corrections can be made concerning the establishment's acceptance of them being old stars. White dwarfs are in the tens of thousands of degrees Kelvin, some even hundreds of thousands. No dead star is that hot on its surface. Dead stars have temperatures in the tens of Kelvin, meaning around 15 to 10 degrees Kelvin, something like that. It was theorized the white dwarfs can cool down to the tens of degrees Kelvin, but since none have been observed in any part of the galaxy, and the universe is eternal according to the eternal universe principle, then the concept of a super-dense Earth-diameter black dwarf, the density of a white dwarf, can be laid to rest. As of 2018, not a single exoplanet has been measured to have the mass of a white dwarf, but not radiate strongly in the visible spectrum. This brings up an extremely important point, one that I have just realized while writing this. The processes behind fusion can only occur inside of electron degenerate matter, and where the matter has a high enough velocity to overcome the Coulomb barrier when it smacks into itself. White dwarfs can be a location for fusion-type reactions as an additional source of heavy material other than AGNs and radio galaxy jets, though they are not dead stars as well. They cannot experience any large-scale fusion-type reaction after large portions of the electron degenerate matter have gained electrons. So basically what we have here is I have a diagram. You have electron degenerate matter, white dwarfs towards the beginning of a star's birth, and mind you, the birthing process of a star is extremely complex and very, very energetic. It's not something where, oh, a cloud just squeezes into itself. That's 1950s, 1940s theorizing. To birth a star, you need to remove the electrons so the matter can get close to itself. And how do you remove the electrons? Large electromagnetic current, and inside of molecular clouds. But that being said, I'm not going to jump too far into that. Once the electrons are removed and the cloud can condense it into itself because it's not being repelled by the electrons, it then will start absorbing incoming electrons, and it will start expanding. And the electrons that it needs will come from asteroids and interstellar dust. And those incoming electrons are going to cause that electron degenerate matter to spread out again, and then the star is going to start expanding considerably. The electron shells will expand and push the entire star outwards like a balloon being blown up. And as it expands outwards as well, it will cool. So you'll have a very, very hot, young, early white dwarf at around 100,000 Kelvin. And as it expands, it'll be like 75,000 Kelvin, and then 50,000 Kelvin, and then 30,000, and then 25,000, and on, until it reaches its largest size, which is a blue giant. And then the concept of plasma recombination comes into play, meaning that all those electrons are going to start combining together and releasing heat, and the star is going to start losing mass and shrinking because it's trying to gravitationally collapse on itself. And that's what fuels a lot of the chemical reactions that take place, thermochemical reactions, electrochemical reactions. Basically, chemistry is going to happen in these things like wild crazy. But that being said, electron degenerate matter in the white dwarf expands outwards and becomes regular matter as it expands to its fullest blue giant stage. And that's at the very top of this diagram here. This is where it starts and expands outwards. And this is where fusion can probably take place because, you know, this is where the really energetic stuff happens, right in this area when the star is very young. Not here. This is the slow, dull area, even though it's, you know, reasonably energetic. But those are much much lower energy reactions as the star evolves. Basically, that's it. I mean, I could read more, but this is on page 236 to 238. And then I have on page 75 to 76, I talk about fusion-powered versus plasma recombination. Of course, as a disclaimer, all of this could be wrong, but it is necessary to think about because a lot of the establishment's ideas are contradictory and do not explain nature to, well, should be anybody's satisfaction, to be honest with you. I mean, when they just have gas collapsing for no reason and rocks self-assembling in a vacuum of outer space, you gotta wonder, what are these people doing? Anyways, today's August 17th, 2018. Later, y'all.